But as I mentioned, today's topic would be introducing and talking about quantum computing and extended reality. So we are going to have Michael and we are going to have Ruslan to speak about these two topics. In case you have further questions, here is their QR codes on of using LinkedIn in case you want to have a discussion with them. And without further ado, let's start the actual meeting and let's start the actual discussion. So, yeah, one of the big topics that came out and worth discussing now is some of the uh, announcements in the quantum space. We have seen, or if you haven't, one of the Nobel Prizes actually went to a big achievement in the quantum world, and this have been, of course, not something that has been done in the last few months by those researchers, rather something like the base research they have been doing. So this is very interesting how quantum is becoming the topic that people are getting quantum Nobel Prizes for. Usually, Nobel Prizes are given for technologies that are well established, well known, and so on. So, quantum is crossing this barrier. The other topic that a lot of companies made wide announcements, whether it's from Google Echo, the whole story about their achieving quantum advancements, and a lot of other companies. So I'm actually very interested what Ruslan and the rest of the people are thinking about this. Ruslan, the stage is yours to share some of your ideas that you might have on this topic. And as usual, this is an open discussion. Feel free to ask questions anytime. It's kind of our special rule to feel free to ask questions. So, Ruslan, stage is yours to share your ideas.
Thanks, Peter. And I should say that I haven't prepared. I didn't realize that this is more of a formal.
No. That it's wait. It's nowhere a formal presentation, so it's not a deck. It's just an open discussion. So no, don't. It's not a presentation. Sorry.
Okay, that's good. All right. I should say that's also my personal opinions. I'm not here representing my organization. I'm here sort of in personal capacity joining this call to chat with all y'all. Now, I think this Nobel Prize this year is very exciting. It's for experiments done in the 80s at UC Berkeley by, let me make sure I have the names, by John Clark and just John Martinez, who was his student at the time, and Michel Devoret, who was his postdoc at the time. Now, all of those had a illustrious career since then. John Martinez led the experimental team at Google for a bit, and he was the man who led the team that demonstrated quantum supremacy back in 2019. So that announcement from Google, that's really the work of his team. And he now has his own startup. So he left Google a few years back. And Michel Devoret is still at Google. He's a kind of a scientific advisor, a senior scientific advisor role there at the Google Quantum team. So the other announcement that Peter brought up earlier, which is the announcement of the Google Quantum Echoes result, it really a result of the work of pretty much the same people who are also receiving the Nobel Prize in Physics this year. So it's quite exciting. The Nobel Prizes for these experiments in the 80s, they did at UC Berkeley. The experiments are about utilizing this Josephson junction-based artificial atom, in scare quotes, which is the same technology that is the qubit used in Google's architecture. So in many ways, the Nobel Prize is awarded for this work that laid the foundation to today's quantum computers, like the ones used by Google and also by IBM. It's very similar technology, the superconducting qubit. And essentially, the central result that is in the Nobel, for which Nobel Prize was awarded, is this observation that you can see quantum effects like tunneling and quantization of energy levels that have been observed in microscopic particles previously, that this team has observed in this large macroscopic object, which is this Josephson junction-based artificial atom, or a qubit, effectively, that they fabricated, in their lab. So that's the Nobel Prize result. And of course, because the kind of thing that went into this experiment, for example, being able to do microwave controls of this artificial atom, these also are the same techniques that, of course, in much more advanced form, are used to control the quantum computers today, like the quantum computer used in the Google Quantum Echoes experiment. Now, on the quantum echo side, on the Google announcement, it's also a very nice result. There's two parts to it. The first result is on the paper that's been accepted in Nature, that's been published in Nature. That is an example of a quantum advantage demonstration. There have now been many quantum advantage demonstrations, then where quantum advantage refers to a quantum computer performing a task that is impossible even with the world's most powerful quantum classical supercomputers. So quantum does something that no classical computer could do. There's been maybe 10 results like this already, including this one from our group at JP Morgan Chase, where we generate certified randomness with Quantinuum Trap-10 quantum processor. So there's many results like this. It's sort of unsurprising that you can come up with some experiments to do on these large now and quite high fidelity quantum computers that you cannot do otherwise. That's unsurprising. And they have a new sort of clever idea where essentially they introduce some perturbation into dynamics of some quantum system, and they measure the impact of this perturbation later on. That's the echo. And they discover that for this kind of random circuit-based quantum dynamics, they cannot do this analysis classically. So in other words, they cannot compute the effect of this perturbation classically that they could observe on the quantum computer. Or it takes a long time to do. So that's one half of that announcement. And the second half is they can also use this technique, this quantum echoes algorithm, to study properties of quantum chemical systems. And they study specific molecules, where they do the same thing. They introduce some perturbation and they do some dynamics. And then, by observing the impact of this perturbation has, they can obtain some property of the molecule. Now, in this case, for the real, let's say, physically existing chemical systems, there is no quantum advantage. That is, if you actually simulate not something that's a random circuit, but instead something that has a real application, a classical computer can also do it. But it's nonetheless sort of an interesting progress towards doing something useful with quantum computers. So let's see. I think that's sort of what I have to say about these two announcements.
Comes the best part of the meeting, I think, where I ask, do you have any questions? Let me know if you have problems unmuting yourself. I know some people have had issues previously. Use the raise hand button if you have issues. I actually spot a few person who is joining for the first time. So again, feel free to speak up. There's no wrong questions here. And it's a very interesting topic that's, yep.
Hi, thanks a lot, Ruslin, for the nice intro. So these experimentation and advancement progress that IBM, Google, Quantinuum, right? These are the main folks that have been keeping up, right? So how close are they to real world problem applications? So that is what everybody would want to know, right? I mean, this mostly is scientific experimentation. How close do you think are they to real world applications?
I think it really depends on what real world is. Some applications are already you can execute now. The question is, of course, how close we are to applications with, let's say, large commercial value, right? Now, what is possible today? Well, first thing that's possible today is you can study certain, systems that are of interest to scientific community that you cannot study otherwise. And these are, for example, some problems in condensed matter, in condensed matter physics, well, really primarily condensed matter physics. These problems have been studied before quantum computers came around with classical techniques, and now they can be studied with these new devices. So in that way, to the scientific computing world, quantum computers are starting to provide value already with these sort of early days small experiments, for example, studying the Fermi-Hubbard model, which is the simplest model for superconductivity, studying other things that are not directly quantum computing problems. These are just scientific problems of interest, but these quantum computers can now address them. That's one example. Another example is the JP Morgan team in collaboration with Quantinuum had a demonstration generating certified randomness. Certified randomness is sort of like a classically valuable thing. It's, of course, somewhat a niche application, right? We want to do much more, but that's one application you can do today already, right? That works, that exists. Now, going forward, you would probably be interested in doing things like simulate, chemical systems for the purpose of drug design. Maybe you want to simulate materials to discover, better superconductor, room temperature superconductors, things like this. So that remains somewhat out of reach. And maybe in a few years, I think there's a reasonable timeline to imagine these things. Again, sort of my personal guess, somewhat speculative, is that maybe in a few years, we would be able to see those experiments come to fruition where we learn something about real world physical systems that are like industrially relevant to maybe pharma, to other organizations.
I just want to emphasize again that, yeah, this is personal opinions of Ruslan's and mine. So it's not like don't make any decisions based on this.
Yeah, nothing I ever say is financial advice. So
yeah, it's not a financial advice.
As they remind us frequently. And then, of course, the other thing is, furthermore, we want to solve optimization problems. For example, in finance, there's many optimization problems that are hard to solve in integer programming, things like this. And there's quantum algorithms for them that have speed up. And running those would be sort of the next frontier after the chemistry and condensed matter. But this is all, I think, much more near term than people realize. I think it is not unreasonable to imagine running algorithms like Shor's algorithm by end of decade. And other algorithms are actually a lot easier to run than Shor's.
Thanks a lot for that. Again, on a very personal sort of a perspective from you, which topology do you think will win? Who are you betting on?
I mean, I worked most with the trapped ion systems. The team that I'm a part of published results on using the Quantinuum trapped ion quantum processor. That's not like the only thing we do, and I've worked personally with IBM and Quera. So IBM is superconducting and Quera is neutral atom. But lately, we have been working primarily with trapped ions.
Also, what's your thoughts on photonics?
It's a very exciting area. There are many challenges. Photons are one of the more, let's say, mature technologies. I mean, people have been doing these like quantum photonic experiments 20 years ago. And one of the first, small, tiny experiments that have been done with photons. Now, to scale, you really need to get loss under control, photon loss, which still is quite high and, impacts your ability to build devices that are large scale. Some vendors make very ambitious targets for their timelines. If they can deliver on them, that's very exciting.
I am in the club of Microsoft when it comes to this, so I am a big believer of the joke, they are holding it differently. So whether they are holding it wrong or not, we don't know yet. But I am in club Microsoft when it comes to this. What they have been trying to do is kind of orthogonal, which is funny to say in this whole quantum world. So kind of orthogonal to what the others have been trying to doing. And there has been cases those who were getting off the way of how the others have been doing is the successful one. So I am bullish on their tech. In some ways intrigues me how they looked at everyone else and said, yep, we will do it from scratch, something completely new, something never been done, something completely new way, needing to invent new materials for it as well, and so on. So I kind of appreciate that they were more daring than others. But again, this is personal opinion. Don't buy Microsoft stocks based on this.
Ruslin, you mentioned optimization with quantum computing and thinking about quantum supremacy with optimization problems. Do you see that more as a milestone or more of a moving target as there's like advances in classical computing now with AI and processes like Google has their AlphaEvolve and other similar optimization techniques? Is there a specific point in time for quantum supremacy with optimization, or does it need to keep advancing as classical computing keeps advancing?
I mean, it's very tough competition from classical algorithm, Jin. Like, there's no question about this. I hope that there will come a time where it's sort of unambiguous, and that the quantum algorithms are outperforming whatever state of the art is. It's always, the way that happened, for example, for the quantum advantage claims in other areas. There was a period, maybe a few years between, let's say, 2019 and 2023, where there was some ambiguity, like, do we have advantage? Do we not have advantage? Initial Google supremacy claim, for example, got pushed back, right? And got removed effectively by progress in classical algorithms. So there was a period of sort of back and forth. And now I think it's sort of unambiguous. We've moved to the point where for these kind of applications, which are, these condensed matter random circuits, there's almost no ambiguity that the quantum computer is doing something that cannot be done classically. Now, presumably, something similar would happen to optimization, where there will going to be a period, and maybe there's going to be a few years where there is some back and forth, and it's not clear who's winning, or maybe one side is going to be winning for a bit, and then hopefully, and that's my understanding based on sort of complexity theoretic evidence and mathematical evidence we have, is that there's sort of fundamental advantages to quantum model that AI cannot capture.
I mean, I'm a big believer that all the technologies that we have been considering now, bleeding edge or cutting edge technologies, quantum chips and all these things, AI, and even probably spatial computing, all these are going to have a singularity point where we will kind of have the fourth or fifth industrial revolution, and we would do things that we don't even cannot fathom right now what we would be possible. I mean, I always look at this steam engine, it made people do things possible that they didn't even knew that they wanted before, So the steam engine has been not just made things faster, it made things possible that we weren't before. I think the singularity of all these technologies, when it come together, I mean, we haven't started using yet quantum chips for AI, neither interference or anything, It's there. One day we feel like it's going to happen. What level of AI it is going to bring? And when I say AI here, I actually mean actual AI, not LLM, RAG, and so on AI, rather AI, the original 30 years ago definition of AI. What will it bring in that area? Cannot even fathom. But I feel like it's going to reach, hopefully in our lifetimes, it's going to reach us this kind of new world of working and everything, and it might actually result in changing how we work, to be honest. If it would be resulting in an army of robots doing the boring part of the work, go for it. Yeah, it might result in this kind of things. Who knows? So I'm very bullish about all this tech and how it is going to change the future for the better. Yes, there's a lot of steps in to reach it. True. But I'm very bullish on all this. Okay. Any other question for Ruslan? Because if not, we actually can go into the other interesting topic that we wanted to touch, everything that happened in the XR space. So there's been a lot of things happening. The biggest one is, of course, Android XR and the new Galaxy XR headset, but also Apple came out with the refreshed version of the Apple Vision Pro using the M5 chip and 120 Hertz refresh rates and a lot of other things. And there has been a lot of smaller things. Magic Leap announced that they are again creating a new device. So, it's a lot of things that has been happening at the same time, kind of unexpected. So, Michael, feel free to
Hello.
chime in. And yeah, we can hear you.
Yeah. Well, so you asked me the other day to talk about this, and I think I can maybe shed some perspective. I hope I can give you all a little bit of help in understanding what's going on, or at least what appears to be going on. There's been I'm going to kind of have to first say that I have a lot of experience in the world of XR. At the same token, I must admit that I have some bias here, because what happens in the world of XR is that you kind of have to at some point get into an ecosystem and decide how much investment of your time, energy, and finances you want to invest in that ecosystem. And as I've been involved in this for the last 30 years, my first VR headset I bought in '96. You kind of get into this is the company that you're going to invest your time and energy in, and they all have different software applications that you can build with, and you kind of have to just sort of go with it for a while. And then of course sometimes you invest your time in things like the HoloLens, and the company drops the support for it. So right now we're at, I would say, I'm trying to guess a good terminology here, but we're watching the first iteration of, or I guess you could say the second iteration of Android's XR endeavors. If we consider the Google Glass of 2014 as their first, we're watching them get back into the game after almost a decade of getting out. And we're also watching at the exact same time Apple's second iteration of their XR device. And if you talk to the people in these different that have been developers for a while, we're having constant conversations about where should we put our time, where should we invest our energies, what devices should we focus on, and the arguments are different depending on the use cases and the applications that we plan to build for. For example, if you're building a game for the masses, then neither the Samsung Galaxy XR or the Apple Vision Pro systems make a lot of sense, because the user base and the anticipated user base is just too small. And so in essence, if you're building a game for one of these devices, you're most likely building for the meta. Maybe you're building a device for a game for the HTC system, but probably you're building for meta just because the user install base is so much larger. Now, the specs on the Meta Quest 3 or the 3S cannot touch that of the Apple or the new Samsung Galaxy XR, but you are asking yourself, well, if I build a game and I charge $20 for it, I'm going to have a potential 5 million customers over here, or 50,000 or a couple 100,000 customers over here. And so it does sort of create this, I guess I would say, gut check moment for a lot of developers, where they have to ask themselves, how much money and time do I want to spend on developing for this? Now, for the Galaxy XR and the Apple Vision Pro, I think what's become clear is that these are developers that are building for what they think the future is going to be, and what they believe the winner is going to be. And sometimes we have to sort of create play this game out and say, okay, we think there's going to be this many users in this amount of time. And this ecosystem is going to be the winner, whether it's going to be the Meta, or whether it's going to be the Android, or whether it's going to be the Apple Vision Pro. So in any case, I'll just say that if you compare the two devices between the Galaxy XR and the Apple Vision Pro, you're going to win the argument for the best device with the Apple Vision Pro M5. We think that the Galaxy XR was maybe slightly better than the Apple Vision Pro with the M2 chip, definitely cheaper by half the price. Lighter weight by 40%. It had a good chip in it.
These two factors, the price and the weight, are significant. The price is obvious, but the weight. So there are a lot of cases where you want to do like a first-time worker kind of thing. Weight suddenly becomes probably even more important than the price.
Well, just think, if you're going to build something that you're going to use 10,000, like let's say you're Boeing or some company that you want to put on the assembly line, and you're going to buy 5,000 or 10,000 of them. If one of them is half the price, it's going to quickly factor in the decision making, right? And of course, like you said, the weight. Where I'm more on the Apple Vision Pro camp, but my use cases are very niche, right? I'm building for helping corporations maybe say make a sales pitch that will win a $500,000 or a $500 million or whatever deal, and in those cases, the cost of the device doesn't factor in at all, and what you're really looking for is the highest quality experience. But those are very small and niche use cases. I will say, I'm not sure who on this call has tried these devices. They're both great devices. Yeah, they're both great devices. It really just depends on what you're trying to do with it. But the cost and the weight are the big factors, the biggest differences. With the newest version of Apple, though, they have kind of set the bar as far as the highest quality you can have on a standalone device in terms of processing power, in terms of visual fidelity, in terms of the field of view, the refresh rate. And I should say something small about the refresh rate. As a guy who's been working in VR for 30 years, initially you had a 30 frame per second refresh rate, which would pretty much limit the amount of time you could play the game. You could play it for a few minutes, maybe a few hours at maximum, but chances are you were getting sick in about 30 minutes or less. When they moved to 60 frames per second, that was better, but still, if it dropped below 60 for just a little bit, you would start to get nauseous again. The new standard is 90, and that's where the Samsung Galaxy XR is. But when you bump up to 120, that refresh rate going up to 120, believe it or not, the brain perceives that information differently. It just sort of becomes smoother and allows you to be in that sustained environment for much longer. Now, the weight is still a factor, but the eyes and the way that it strains your eyes, the 120 is a nice bump over the 60 and the 90 on the Samsung Galaxy XR. So, and all these factors, I will say that we're not done yet, right? I think what we're going to see, especially from Apple and from Android, is we're going to see the next couple devices are probably going to be mixed reality only devices. They're not going to be the full headset. They're going to be more like the Meta display glasses. We expect to see that from Galaxy, from Android. We expect that Apple, the rumor is that Apple is going to focus now on lightweight glasses that compete with the Meta display device. And I think that probably this M5 device was in the works for quite a while. They announced it only about a month or two ago. And then shortly after they announced it, you could buy it. Whereas when they announced the first one, they announced it and it was about I think 10 months or 9 months from when they announced it to when you could actually get your hands on it in the public. So we think that we're probably not going to see another Apple device until the next one. And I should say this is kind of the rumor mill. These are a lot of the people that talk about what's going to happen. That there will be eventually, hopefully, another version of the Apple Vision Pro, but that this is it for a while. So the next device will match that Meta display, and we'll have a much more limited specs on it. It'll be lighter, much lighter weight. Obviously, it'll have the Apple ecosystem and the Android ecosystem for their glasses. But it's a totally different use case. It's a totally different type of device. It's not built for viewing movies. It's not built for checking out some cool game. These are going to be for your daily use, and they're going to interact with Apple Intelligence and Gemini. So we're at that stage now where I think they've released their top end devices, and we're going to see the next iteration. And we're probably, and I've been predicting this for a while, like when will we see these different versions of devices? My guess is we're probably 3 years, 2.5 to 3 years away from the next Apple, immersive virtual reality experience device. And I don't know about Galaxy, maybe less than that for the Galaxy, but they're going to focus their energies now on something else. So in the meantime, there are still going to be applications that make sense. I think businesses will, once they start, we're pitching our services to some big entertainment companies and enterprise companies, and they're starting to see the value of collaboration with personas in the Apple Vision Pro, sharing assets and having heightened experiences. And for those of you who have the device, I have to tell you, if you've ever taken an Apple Vision Pro on an airplane, whether it's the M2 or it's the M5, it's an incredible experience watching a movie on an airplane, and you cannot imagine what that's like unless you've actually done it. Imagine being in an IMAX theater while you're sitting in your economy seat and you're watching a film that feels like you're in your own private IMAX theater, because that's what it's like. And then the flight attendant will reach into your IMAX theater and ask you if you want another soda or something like that. But in the meantime, it's incredible. So like consuming entertainment, consuming content on both of these devices is really incredible. So when you get a chance to either have one or try one out, I suggest you try to watch some 360 films, some 180 3D films. It's really incredible, and both devices do a really good job of that. I think that's all I'm going to say for now. Again, I
actually want to. I don't let you go this easy.
Okay.
So I want to pick your brain
Yeah.
on the other companies. So Magic Leap,
Yeah.
surprising announcement.
Yeah.
Snap, doing spectacles and a lot of things happening there. Very surprisingly strong hardware, very hard to use SDK, at least based on my findings. So what is your view on this new, and of course X-Real with their own set
Yes.
of glasses. So we have some more niche players
Yeah.
in the market. So what is your take on those?
Again, I go back to the idea that the use case is the dictator on who gets the money and the attention and the time. And I do say that as a company, my small business has been doing this for a long time. We're constantly getting the requests from these companies, and I think all developers are like, hey, become part of our ecosystem. So for example, Snap. Snap has been very nice. They've rolled out the red carpet. They've been very kind to developers. They've offered a lot of incentives for developers to get in on the ecosystem. And then there are those who will invest their time and energy in that. But the Snap glasses are amazing, yet they have huge limitations. You're not going to wear the battery's life is not very long. The Meta glasses won't do what the Snap glasses do, but the battery gives you a lot longer use case for them. So again, in every situation, and Magic Leap as well, right? I think there's a lot of people in the industry who were kind of surprised to see that Magic Leap's announcement, but that's just, yeah.
I was so surprised. I was like, wait, the Magic Leap?
Yeah. I've got friends who work at Magic Leap or who used to work at Magic Leap, and they thought that the company was not going to make it. So to see that was quite an announcement. But again, I think that we are at a time when there's all these different companies lining up, and essentially, I think what they're all kind of shooting for, one way or another, is the eyeballs of the consumer of the future, right? Like of where we're going to be in a few more years, maybe 5 more years, maybe 3 more years, when and this is one thing I haven't said yet, but I think that the large language models, all the different ways in which we interact with these systems, we all interact with them usually either through a text or a voice solution. But I think in the not too distant future, it's going to be a 3-dimensional, whether that's video 3D or some version of combination of spatial intelligence mixed with AI intelligence. But when that starts to happen, these devices are kind of going to be our interface layer. Instead of speaking to the AI, which is great, we're going to have more contextual information if we can share our world and we can see additional information. Like, for example, I was working on my Karmagia the other day, and I was trying to fix a problem with the strut. And, I got a little bit of information, but if I was wearing glasses and I could look at the problem and the AI could say, oh, your problem is that your torsion bar needs to be adjusted, that's going to happen. And that's going to happen in the not too distant future when more of us are wearing these devices and the information is being shared. And we're getting, immediate feedback. What also would have been nice would be to look at this undercarriage of my Karmagia, and it tells me, oh, you got to adjust the torsion bar, and say, this is the nut you've got to tighten right here, and you're going to need to bend this back right here. That's coming too. And I think that, like you said about the steam engine, we cannot even imagine all of the use cases that are going to be coming when we start to see the convergence of these different technologies. Once we see this quantum computing, once we see the AI, once we see the user interaction on spatial devices becoming much more ubiquitous. So I think this is everyone is lining up to play their hand, and there's obviously everyone's not going to be a winner, right? I don't think that we're going to see X-Real and Apple Vision and Galaxy XR, and obviously Microsoft kind of bowed out. But I've heard rumors that Microsoft might be coming back. Who knows? I've heard that. And I think that everyone's making a play, and there's not going to be enough eyeballs. There's not going to be enough for everyone to win. So what we don't know yet is who's going to bow out And I will say one other thing. I think that what we're going to eventually have is the ecosystem is going to be the winner, right? So it's going to be the Apple ecosystem, or it's going to be the Android ecosystem, or it's going to be the Meta ecosystem. And right now, those are the top three. But once you buy into that ecosystem, you might say, okay, well, I'm going to wear my display glasses throughout the day for most of my use case, and it's not going to be necessary to use AI or the 3D version all the time. But then when I need to get into something where I need the 3D, whether it's a game or whether it's an application for work or whatever, I may change out my Meta glasses for the powerful, VR glasses. I used to think it was going to be all one device. I kind of moving away from that being one device. And now I think it's going to be one ecosystem where you're going to have your user account, and you're going to have the system and your AI agent that you're connected to all the time. But you're going to probably be locked into the ecosystem, because it's going to be hard to move from Apple to Android to Meta. That's not going to be easy.
So it's very interesting. So I was having this discussion with someone on the other day, and they told us that, yeah, I'm not going to have multiple glasses, one this and that way, because I'm not having multiple phones. And I was like, no. It's like having a phone and a Mac.
Yeah.
It's not two headsets. It's technically two. It's not the two of the same category of devices. The same way you have a mobile phone and you have a laptop and you are not using them, and sometimes a tablet, and there's three devices you are using for different things, and you probably even have some Apple TV device on your TV. So again, these are all in the same ecosystem and the same everything, very different. So think of the VR glass and AR glass and all these things more like this, if it makes sense. How I mean the difference between these.
I agree with you 100%. I think that's what's going to happen. And I think we're years away from that. But the question is whether these glasses will be useful enough to make the case that it's worth the money to the consumer. And I don't know when that's going to happen for sure. I think that's still a few more years out.
I remember how cost of phones and laptops started to increase significantly, and people are willing to follow it or continue with it. It's not like they stop paying for them. So I feel like that it's more about what these devices are able to do.
Yeah.
More like, so if you would be willing to pay for it if the device is doing what you specifically want.
Exactly. The iPhone 1 was, I think, about $600 list price, right?
Exactly.
Yeah.
And
now
and
that's
and, and,
high-end is 100. Yeah.
yeah, and look at the iPhone 1. It didn't have copy paste. It didn't had 3G. It didn't had App Store. People still liked it. Look at the Apple Vision Pro and the Galaxy XR and everything. These are all V1 devices. I hate calling them, but these are in terms of breaking into a new market devices.
And if they're following, go ahead.
Yeah. No.
No, as I say, if they're following the price structure of the HoloLens and the Magic Leap, they're actually in the same price point of those devices, and they do so much more. Now, granted, we are 7-8 years later, but they do so much more than the HoloLens and the Magic Leaps of the day did, and they're in the same price range. If you figure in for inflation, they're actually considerably less than those devices. Yeah, it's an interesting time.
Definitely is. It's the Chinese proverb, I wish you live in interesting times.
Oh yeah, well, we are.
We are.
It's hard to keep up with it, I can tell you that.
It's very hard to keep up. I am super much into this business like you are, and it's super hard to just keep up. It's nearly impossible.
Are there any questions?
Yeah, questions, comments, feel free to raise it. If you need help to unblock, or just let me know and I can help you.
There are only two of us left here, I think. But no questions. Thank you. It was very interesting. I appreciate that. Again, yeah, I was here last meeting as well. I work in tax operations here in the same building on a different floor, but I'm interested in tech personally. So I'm thinking in pivoting maybe at some point through a master's degree. So hopefully that's why I'm personally very interested in the topic.
You know, the joke is that you might be doing a master degree from an area we don't even know yet.
Yes,
You know,
hopefully.
come on. And now you can do a bachelor from prompt engineering. If you tell me this 5 years ago, I would be laughing.
I see. So yeah,
So,
life is is like that. You never know.
okay, cool.
Thank
If
you so
nothing
much.
else, yeah, oh no, go for it. Sorry.
No, I was just gonna say thank you so much. It was an interesting session. I came after a long time though, like, yeah, but it was really nice to hear from both the speakers. Thank you.
Thank you very much.
Thank you.
So, if you are not part of the Zenith Mail group, feel free to subscribe to it. Otherwise, see you guys on the next one. And I would like to thank both Michael and Ruslan for providing a lot of interesting insight here. Thank you very much, both of you.
Of course.
Thank you. Thank you, Peter. Thank you, Michael.
Thank you. Bye-bye.
Have a good one.